Hello, I'm Philip Stoughton for EMS Now. I'm here at Productronica 2013. I'm joined by Brian Lau from DEK. Brian, great to see you. Thanks for stopping by. Last couple of days at the show, there's been a little bit of optimism building here. Some positive signs in the German market. I think maybe partly through the just length of time it's been flat and people wanting to push out. But in terms of investment, what does that mean for you guys? Capital equipment, process improvement? What are people asking for this week?
Well, I think some of both, obviously, and really the differentiator for DEK is that we offer that total solution. The German market is always an early adopter of technology, so while there's been a pent-up demand due to kind of this previous slowness in Europe, the technology changes haven't been as slow. So where they are now needing to print finer, more automated processes, less operator intervention, smarter processes, that definitely gives us opportunity to serve that market.
Yeah, absolutely. I guess that means that even though there is a downturn, you've got to push just as hard, if not harder, with the R&D. As a result of that, what have you been able to bring to the market this week to show people?
Well, we certainly have a whole suite of capital equipment things that we have brought. Most of it around automating some of the processes, allowing the operators to be more efficient in what they do. But then also from the process support products, things that are enabling them to either improve their throughput, improve their yield, or reduce their cost of ownership. Things such as our VectorGuard high tension, as an example.
Yeah, and the high tension, what's the reason for? Clearly has a higher tension on there. What's the demand reason for that?
Well, the demand reason is as you get to smaller and smaller apertures and more densely packed circuit boards, the tension has a lot to do with the release of the paste onto the board. So if there is a spring effect, say from a looser tension, that exists in some of the mesh mount stencils and things like that, what you actually end up doing is deforming that paste deposit. Right. And in those really small deposits like 0.105s and 0.3 CSPs, that has a big effect on yield. So by having a much tighter tension, the release is much more controllable, much more repeatable, and provides that better release.
Okay, and is there a playoff there in terms of the life of the stencil by actually increasing that tension? Does it last less time, or? Well,
as compared to, for example, a mesh mount stencil, yes, it lasts a lot longer. Because what happens with a mesh mount is that tension that is held by the mesh starts to decrease. Right. So over the lifetime of that stencil, you start to lose the repeatability. Because VectorGuard is an all-metal foil, we never lose that. Okay. So, from print 1 to print 100,000, it's going to have the same tension across that stencil. Okay,
and typically if we compare VectorGuard with VectorGuard high tension, what kind of percentage of additional prints would we get out of the same stencil pattern?
Oh, well, it's about 66% tighter tension. From a lifetime standpoint, they're very similar because they're both going to be a all-metal foil. Yep. But from a repeatability of that process, print to print, it's going to be much greater with the high tension.
Okay, and then the additional cost in terms of the
same
trade-off
cost.
There? Wow.
Same cost. So, we're enabling the customers to have a better process.
So you're giving them a benefit, you're giving them more longevity in the same price. Why would be the question there, but I guess.
Well, why would they not
smaller,
switch?
Faster, cheaper is what everybody wants.
Absolutely. Yeah. It's a very competitive market in the stencils. We need to be able to continue to offer them greater value. So if we can do more at the same price, they see that as a better value.
Yeah, and as the solder paste depositions get more and more complex, you're starting to do some 3D things on the stencil itself. How does that work?
Yeah, quite a bit of work on that. So there are many processes that in the past have been done with dispensing, and the reason being is that they were at different levels. So traditionally, printing worked very well as long as everything was in a planar surface. Right. But the problem with going to dispensing, one is it's not as consistent. Dot to dot, it's going to be a variation. The other problem is it's just slow. So if you have 10,000 apertures, or 10,000 dots.
You've got 10,000 dispense.
It's very slow. So what we've worked with many of our customers now is what we call three-dimensional cavity printing, where we're actually now printing in multiple dimensions on the circuit board.
Right.
The reason they're interested in being able to do this is obviously products continue to get thinner, and the thickness of a circuit board is what it is. But what if you can now start to embed some of those components into the circuit board, you can start cutting millimeters off of the total height of the product. The other thing is that the signal speeds of the processors are going up.
Yep.
the more layers and interconnects in the circuit board that they need to go through, the less performance they get.
Right.
So now if they can actually put the processor at the level of the circuit board,
Okay.
they get much better performance out of the circuit.
Yeah, so we're seeing that change in the profile of the circuit board. We're not on a flat surface there. And when you're doing that, are you having to change their capital equipment, or are you providing them with add-ons, or is it just a different stencil?
Actually, it's just a different stencil and a different squeegee mechanism. So it's a very easy conversion for them.
Yeah.
It does require a fair bit of engineering and working closely with them, but we have the expertise to be able to solve their printing problems.
Yeah, and that plays very much to the strength of protecting their investment. And for something like that, they don't really want to make major changes, and they need the flexibility in the line, I guess. Absolutely. And I know, Brian, you take care of some of the solar stuff as well.
Yes.
And for the first time in some quarters, we've seen some improving...
Maybe some years.
Yeah, some improving projections.
Yeah.
And they remain projections, but there are positive signs. Is that just what we're seeing from the consultants, from the journalists, from the bloggers, or is it something you're seeing out there when you're talking to customers?
I think we're seeing it across the value chain right now. So, from the standpoint of it was first started to appear with the analysts. If we look at the top 20 solar manufacturers, their stock prices have been increasing. And the reason it's increasing is because the global demand is increasing. This year, it's expected that the global demand will be somewhere around 36 gigawatts.
Okay.
That still doesn't solve the oversupply issue, because there's about an effective capacity of 45 gigawatts. But the reason everyone's so optimistic is 2014 is expected to kind of be the inflection point where supply and demand start to equalize, and then 2015 where they definitely need to start adding significant capacity.
And as they get towards that inflection point, the smart manufacturers of solar cells need to be ahead of the game. And I guess they're not just going to be saying we want to add capacity of the same machine we bought 4 years ago. They're going to want the next generation. Are you ready with that?
Yes. So the big pressure that they're under is to really reduce their costs and increase their efficiency. So they're looking for more throughput. They're also looking for reduction of cost, and one of the most expensive costs is the laydown of silver on the cell itself. So going to fine line, high accuracy printing. And we're very well positioned to support that.
Okay, and that's actually using less material, so it's an economy in that way, or it's just
much less material. And the other advantage is that by using thinner lines, you have less shadowing of the cell itself.
Okay.
So the actual cell efficiency increases as well.
Which again is a very important factor. Yeah. Okay, so a bit of optimism in that market, some new products in the SMT sector that sound exciting.
Yeah.
Hopefully 2014 is going to be a good year.
We fully expect it will be.
Okay. Brian, thanks for stopping by. Thanks for
you.
chatting.